Hello everyone. So today we are going to see the keyword inline. So it is many of the times asked in the interviews that what is the meaning of inline and where do we actually use it? And most of the candidates come up with the solution of optimization. But apart from optimization, it has different meaning as well. So let us go into depth of inline keyword. So the first thing is the optimization, which is a compiler hint. It suggests to the compiler that try to expand the function body inline instead of making a call. So this is done by the inline keyword. But the modern compilers, they ignore this hint, then they decide the inlining on their own. So the next thing is that the inline keyword does is the linkage or the ODR meaning. So ODR stands for one definition rule. A function marked as inline can be defined in multiple translation units without violating one definition rule as long as all the definitions are identical. So it says that if you have a function and if you are defining the function in different translation unit, it means different files, then it will violate the rule of one definition rule and it will give you an error. But you can overcome this error if you mark your function as inline, which means that the definition of the function can be linked at the compile time and they will be merged even if there are multiple definitions. But the definition should be identical. So let us understand this with an example. So I'll create a file, say point.cpp or point.h, a header file, point.h. Inside the header file, include iostream using namespace std. Then I'll create a class point which will be having two variables x and y. So class point will be having say int x equals to 1 comma y equals to 2, and I'll overload the extension operator. So friend s we can avoid using std. O stream reference operator, O stream reference, let us name it os, constant point reference p, and we are going to return the os, and before returning we'll log it out. So then we have p dot x. After that I'll separate it by comma, and then p dot y, and then we have the closing parenthesis. So with this the point class is done. Now let us create another file which is main.cpp, main.cpp, and inside the main.cpp I'll include the point.h and I'll create an object of point. So hash include iostream, hash include point.h. Then inside the int main method, I'll create a point p and I'll just say cout p. I'll also create another file which is other.cpp and we'll be having hash include iostream using namespace std. We have void say test method where we create point p and cout p. But first of all, we have to include the point class. So hash include point.h. So till now, we have created a point class in point.h header file, and we included it in main.cpp, and we also included it in the others.cpp. Now, if I'll try to compile it, so if I'll say g++ main.cpp and other.cpp, and let us name it main. If I'll compile it, then you would see it compiles successfully, right? Even though the same class point is loaded inside the other and main both. They are inside the different translation unit. You have see the same class, but still you are not getting multiple definition error. So let us also try something else and understand why we did not got any error and what actually do we need to do. So let us have another function called add, and say it takes int a comma int b as an argument, and it just returns me the a plus b value. Right. It's a simple add function which takes two integers and returns me the summation of both the integers. Now if I'll try to compile it, you will see an error which is multiple definition of add. So this is why we use the inline keyword. So this add method is going to be included inside the main and other. So in both these files, we have two translation unit where the same function has been defined. So here you can see we have the other.cpp and the second is the main.cpp, and we have multiple definitions over there. So by marking it inline, we'll be telling the compiler that at the time of linkage, just link these two methods and merge them, and they will be having identical definitions. So with this inline keyword, if I'll try to compile it now, the linker will link them together since they have the same or identical definitions. Now, why do we not require any inline keyword in case of the point class? The first thing is that the classes do not use any inline keyword. The inline keyword is only used with the functions and the variables, because the linkable objects are only generated with the function variable. Linkable objects are not generated by the classes. So you cannot mark any classes inline. Now the second thing is that the functions which are present inside the point class. So if you have another function, let us say we have, say, int compute, which returns me the p dot x plus p dot y summation. Now this function, okay, well, we have to also pass. No, we don't need to pass it. We can keep it in the public section, and it can still access all the variables. We should remove the p, so it can directly access the private members of the class. So there is a compute method. Now all the methods which are there inside the class and which have the definition inside the class, they are marked implicitly inline. So even though you have not explicitly marked this function as inline over here, but by default, this function is already inline. So even if I'll remove this and try to compile it, it will not give you any error. But what happens if I remove the definition from the class and keep it outside the class? So let us say I'll just have this function. I'll copy it. I'll keep it outside since it is a friend function, so we can define it outside as well. So I have the definition outside the class, and I'll remove the definition from the class, and I'll just make it a declaration. So till now, you have a friend function, which is the operator, exertion operator, and we only have the declaration inside the class, and the definition is outside the class. Now, if I'll try to compile it, then the compilation will fail. Again, it says the multiple definition of operator exertion. Why? Because the functions which are only declared inside the class, but their definition is outside the class, they are not marked as inline by default. We have to make them inline. Now, if I'll make it inline and if I'll try to compile it again, it should work. So the main purpose of using inline keyword is only to allow you to use the ODR rule, which is the one definition rule, so that if you're having multiple definitions inside multiple translation unit, then your linker should be able to merge them together if they have identical definitions. So I hope you have understood the meaning of inline. I have also made the notes, plus I have highlighted all the points inside it. So one more thing, that inline keyword has a slightly different meaning in case of the namespace. We will see this inline keyword for namespace in a separate video. I'll create a complete separate video for namespace inside which we can cover this inline.